Next thing that you need to know how to do is prove identities to be equal. That means we give you, okay, let's just first talk about these. These are the different identities that you need to know at grade 11 level. And the first one is sine squared theta plus cos squared theta equals to 1. I've highlighted the 1, so that's the subject of the formula, and then I've highlighted these two so that I made them the subject of the formula. How did I do that? I just took the cos over here so that I could have sine squared alone, and in this one here where I wanted cos squared alone, I took the sine squared over so that it's like that. And the other identity you need to know is sine theta plus cos theta equals tan theta. So I wrote down one of these questions and I'm going to show you the method on how to do it. Okay, so you need to write down first left hand side, and then you need to write down your right hand side separately. You always look for the more complicated side to work through. In this particular case, can you see my left hand side looks more complicated? Why is it more complicated? Because it has firstly more terms, and secondly, can you see it has a tan x which could potentially open up to that. So this here is going to be cos x over 1 plus sine x plus, this is going to be sine x over cos x. Now once I have something like this, I end up with a fraction, and then I'm going to use my grade 8 and 9 knowledge of LCD. Okay, so my LCD is going to be 1 plus sine x multiplied by cos x, 1 plus sine x multiplied by cos x. This one here, to get from there to there, I needed to multiply by cos. So this here at the top is going to be cos squared x, because what I do at the bottom I do at the top. Same thing over here, I had a cos x, there's it over there. I needed to multiply by 1 plus sine x, so that means my numerator becomes sine x plus sine squared x, because I multiplied this here by sine. Okay, I can also see in my numerator, I'm going to add this plus this. It gives me 1 plus, I'm left behind with sine x. How did I know that this and this must get added? Because we know the numerators are over the exact same denominator, and I know cos squared x plus sine squared x is what I have over here. Just here it has theta, and we know it's equal to 1. I then have the sine x as left behind, or a remainder, right? Then in my denominator, I have 1 plus sine x multiplied by cos x, right? You see that our whole numerator can cancel with that, and that's possible because in the denominator I only have one term, right? And I am left with 1 over cos x. If you remember, that's exactly what my right hand side was supposed to be. Let's just write that down, the right hand side. Therefore, left hand side equals right hand side. A few tips for doing this. Sometimes it doesn't always work out perfectly the first time. So when you're practicing, my suggestion to you would be work it out in pencil, practice a couple of them, and then see how you're doing. The nice thing about it is you'll always know if you're right or wrong. If you come to the bottom here and you see your left hand side and your right hand side are equal, you know that you've got all the marks. What else do you need to know? So I wrote down the two identities. You also need to know difference of two squares. You need to know how to factorize a trinomial, and you also need to know how to manipulate something. Okay, let's try one. Let's do this one over here, just so that I can show you how to manipulate. This is our left hand side, and our right hand side, let's draw a line. Our right hand side needs to be sine theta over 1 plus cos theta. You also need to know when to make a judgment call as to opening up the 1 as sine squared plus cos squared, or just leaving it as 1. And that really comes with some practice, okay? The thing is, don't open it up in all cases. You need to look at your left hand side and right hand side. If you see a 1 over here and you see there's a 1 over here, that means chances are they remain in the same. In some cases, if you see a 1 over here but there's no 1 on the side, chances are that we opened it up somewhere and got rid of it by factorizing or cancelling out. Okay, in this particular case, can you see I have a 1 minus cos there and I have a 1 plus cos here? Okay, and then I have a sine theta and I have a sine theta. So we know that we need to do something slightly more different, and it doesn't require any of these identities yet. So we're going to do some sort of manipulation, and I'm going to do that by saying multiply by 1 plus cos theta over 1 plus cos theta. Now if you think about it, this over this is basically 1. Any number or any term multiplied by 1 is the same. So I didn't actually or technically change this in any way. All I'm doing is I'm manipulating it in such a way so that I can end up with difference of 2 squares in the numerator, and I can end up with this in the denominator because that's what I need. Okay, difference of 2 squares, like I said, would give us 1 minus cos squared theta over my denominator will have sine theta multiplied by 1 plus cos theta. Right? Then if you look at this part over here versus this part over here, you would see that in my numerator I have a sine theta. So then I know that I need to change this using this identities over here. So I have 1 minus cos squared theta, so it's going to be the same thing as sine squared theta. So sine squared theta in my numerator over sine theta multiplied by 1 plus cos theta. You would then notice that the sine theta can cancel with the squared there. So I end up with, in my numerator, sine theta over 1 plus cos theta. And that's exactly what they wanted us to get to. So therefore, my left-hand side is equal to my right-hand side. So as I was saying, you need to know your rules of factorization. You need to know when to manipulate something. You need to know when to make a judgment call and open it up. And you need to know how to open up a tan theta and simplify with that. And that's all that you need to know with identities. It does take some practice. So my suggestion is that you do practice quite a bit. I have sent the chapter on trigonometry from Classroom Mathematics, so you can try working through it.